Good morning friends, welcome back to Parnika tutorials. In this video, I want to discuss about translation look-aside buffer, which is TLB, in detail. So I request everyone to watch the complete video for better understanding. In paging, a process is logically divided into pages and main memory is divided into frames. Okay, now if process is divided into pages and main memory is divided into frames, the page size will be equal to frame size. Meaning is that one of the page of a process can easily fit in one of the frame in main memory. Is it clear? Are you able to understand it or not? Let's consider that a process P1 is logically divided into 10 pages starting from page number 0 to page number 9. Now, page number 0 is stored in frame number 1. Let's take that. In frame number 1, page number 0 of process P1 is stored. Similarly, in frame number 3, page number 2 is stored. In frame number 4, page number 5 is stored. In frame number 9, page number 6 is stored. Is it clear? Now, we need to store this information somewhere. A process particular page is stored in which frame of main memory. So that's why each process will maintain its own page table. The number of entries in a page table will be equal to number of pages in a process. Let's consider that this process has 10 pages starting from page number 0 to page number 9. So the page table will have the indices as page numbers. Page number 0, page number 1, page number 2, so on up to page number 9. Now, what this page table will consist of? It will consist of several information such as that frame number. Meaning is that if page number 0 is available in the main memory or not. If it is available in the main memory, in which frame it is stored. So the frame number will be there, and also it will have the other optional bits such as present or absent. What is the purpose of present or absent bit is that whether the particular page is available in the main memory or not. Let's consider that the present or absent bit is kept as 0 for a page number 0. The meaning is that page number 0 is not available in the main memory. Is it clear? Then we will have other information such as cache enabled or disabled bit. We will have the reference bit will be there, and then we have the dirty bit will be there, and then we have the protection bits are there. So regarding these optional bits, I have discussed about the page table structure. There you can refer it. But here we want to discuss about the TLB. So what I want to say is that let's take that page number 0. Page number 0 is available in frame number 1. So it will be there frame number 1. Similarly, page number 1 is not available in the main memory. So the present or absent bit will be 0. So meaning is that the page is not available in the main memory. If it is not available in the main memory, how can we give the frame number? Is it clear? Similarly, page number 2, look at page number 2 is available in the frame number 3. So present or absent bit will kept it as 1. Meaning is that it is present in the main memory. Similarly, page number 5 somewhere here is there in the frame number 4. Is it clear? Are you able to understand? And page number 6 is stored in frame number 9. Is it clear? So present. Now, usually the CPU generates the logical address. The logical address consists of page number and page offset. Okay? And remember one thing. Now, if you want to convert the logical address to physical address, the memory management unit will convert the logical address to physical address. For that conversion, page table will plays a major role because CPU is searching the page number 4 of a process P1. Let's consider that. Now, process P4 is stored in main memory. In which, page number 4. Is it clear? Page number 4 of a process P1 is stored in which frame of the main memory. Somewhere you need to store. That information is available in the page table. So this page table also we need to store somewhere. Am I right or wrong? So where we will store? We will store it in the main memory in one of the frame. if it is a single level paging. Is it clear? Suppose let's take that this information is available in frame number 15. So page table of process P1 is available in the main memory frame number 15. So CPU will always maintain one register. Okay, whenever it is accessing a particular page of a particular process, first it will look at the page table base address register we will have. Okay, we will have one register. In that register we will have the page table base address. What is its base address? Meaning is that in which frame or what address it is stored. Is it clear? This frame number starting will be some address location now, because usually main memory is a collection of addresses only. So this address will be stored here. So first it will go to this address and access the page table. Suppose now it wants to access the page number 4. Suppose let's take that page table base address is 100. Okay, then plus 4 you will do, you will go to the page number 4 in the page table. Then you will check whether the page number 4, this entry, suppose this is the page number 5, this will be page number 4. Now page number 4 is not available, 0. So if it is not available, we will say that page miss. Whatever the CPU is accessing for a particular page is not available in the main memory, then we will call it as a page fault. If it is available, we will call it as a page hit. Suppose let's take that CPU is accessing the page number 0 of process P1. So it will go to the base address and then it will go to the page number 0. Okay, page number 0 is available in the frame number 1. So it will give the frame number 1 information, and this page offset depends on the size of the page, and we know that size of a page is equal to size of a frame. So page offset is equal to frame offset. So you will get the frame number 1 and frame offset. Then you will go to the main memory and access the information. Is it clear? If it is a single level paging, we can keep the entire page table in one of the frame. Is it clear? Now if page table size is greater than the frame size, then obviously we cannot keep the entire page table in one of the frame in the main memory. Then what we will do? We will go for the multi-level paging. Meaning is that this page table again we will divide into pages, and then we will keep another page table to get this information. Is it clear? Suppose let's take that if it is a 2-level paging. Is it clear? If it is a 2-level paging, we will have the outer page table. Okay, let me keep it as OPT, outer page table. Then we have the inner page table. Let me keep it as IPT. Then we have the main memory. So first CPU will access the outer page table, then it will access the inner page table, and then it will access the main memory. Now this outer page table and inner page table, where they are? Again they are in the main memory. So what is the problem with this kind of access is that even the page table is there in the main memory. So one main memory access is required to access the page table, and another one main memory access to access the particular instruction. Is it clear? Are you able to understand? Suppose let's take that frame number 1. You have to go to the frame number 1, then access the page number 0. So one is main memory access is to access the particular page. One main memory access is required to access the page table, and the size of the main memory is usually high. Nowadays we are going for the 4 GB, 8 GB, 16 GB. Okay, we are going for the RAM. See, main memory is what? Your RAM only. If your main memory size is increasing, if the search space is increasing, then access time will also increase. Am I right or wrong? See, if you are searching me in my home, will be less time. If you are searching me in my city, then obviously the city will be larger, then access time will be more. Am I right or wrong? If you know my house address, if you come to my house, if I am available in my home, then you will search it very less time. Suppose if I am not available in my home and my family member said he went to the market somewhere, then searching me will take lot of time. Is it clear? Unless until you have my mobile phone number, you call me, all these things, that is secondary thing. Is it clear? So if the search space increases, the searching time also will increases. So let's consider that main memory access time is 50 nanoseconds. Okay, then effective access means to access that particular information, 150 nanosecond is to access the page table, another 50 nanoseconds is to access the page. So totally 100 nanoseconds it is taking. Is it clear? So then researchers or the developers thought that it is taking lot of time. Why can't we introduce another memory, and in that memory can we store these page table entries? Then they introduced the concept called TLB, which is translation look-aside buffer, which is nothing but your cache memory in the computer organization course. In computer organization course, I have discussed enough about the cache memory. Is it clear? Now, cache memory is even also called as associative memory. Is it clear? Now, it has the tags. Now, what we usually will do is that as the cache memory size is less as compared to the main memory, because the cost per bit in the cache memory is high as compared to the main memory. So if you want to increase your main memory is cheap. If you want to increase your cache memory, it will be costly. So the cache memory size is less as compared to the main memory, but the access time in the cache memory is less as compared to the main memory. Obviously, if search space is decreasing, the searching time also will decrease. Is it clear? So what we usually do is that instead of keeping the entire page table, okay, we will keep the few entries of the page table in the TLB. Is it clear? Suppose let's say that I have kept the page number 0 information which is available in the frame number 1. Similarly, page number 2 information I have kept it as frame number 3. See, I am not keeping the page information. I am just keeping the page table information, meaning is that page number 2 is available in the frame number 3. What information inside the page we are not keeping here. Are you able to understand it or not? Similarly, let's take that page number 5 is available in the frame number 4. Now what usually we will do is that let's consider that CPU is trying to access the page number 0 of process P1. Then instead of searching the page table, first it will search in the TLB. Now in the TLB, page number 0 is available. Page number 0 information is available. Is it clear? So if that information whatever you are searching is available, then we'll call it as TLB hit. Okay, so what information it is saying? Page number 0 is available in the frame number 1. So it will convert the logical address to the physical address with the frame number 1. Then we will go to the frame number 1 and access the information which is available in the page number 0. Is it clear? Are you able to understand? So if TLB hit is happening, what will be the access time? The access time will be, if TLB hit happens, then it is access time for accessing the TLB and main memory access time. So this is about the hit. Now if it is a miss, meaning is that whatever the CPU is searching, that information is not available in the TLB. Let's consider that page number 6 CPU is searching. Is it clear? Now page number 6 is available in the TLB, page number 0 is there, page number 2 is there, page number 5 is there. So page number 6 is not available. If that information about the page number 6 is not available, then we will call it as a TLB miss. Okay, if TLB miss happens, then what will happen? Then we will look at the page table. Okay, page number 6 information is not available in the TLB. Then it will search the page table. Okay, where the page table will be there? Page table will be there in the main memory. So first we will access the main memory to get the page table, and then we will access the page number 6 which is available in the frame number 9. So we will convert into physical address. Is it clear? So if it is a miss, to know that whether the information is available or not, you have to access the TLB. If you access the TLB, then only you will understand whatever the information you are searching is there or not. So if it is a miss, you have to access the TLB, then only you can say that it is a miss. Then you have to access the page table, meaning is that you are accessing once the main memory. Then again you need to access the main memory to get the particular page information, means particular page, means particular instruction you are getting. Is it clear? So if it is a hit, you are accessing the TLB and the main memory. If it is a miss, TLB page table, meaning is that it is nothing but main memory access only, because the page table is there in the main memory. Let's consider that this is a single level paging. If it is a multi-level paging, I will discuss for you. If it is a single level paging, meaning is that entire page table is there in one of the frame, so one access is required to get the page table. Okay, then main memory access. Is it clear? If it is a two-level paging, then two levels you have to access. So two times you have to access the page table. So two times you have to access the main memory. Then again once you need to access the main memory to get the particular thing if it is a TLB miss. If it is a TLB hit, only once you need to access the TLB and once you need to access the main memory. Is it clear? Suppose if it is a three-level paging, if it is a miss, then three times you need to access the page table, because you will have a outer page table, then you have another page table, then you have the inner page table. All this information will be available in one of the frame of main memory. So outer page table, first you will access the in main memory of a particular frame. First you will access, then again to get the inner page table you have to access, so then you have to access the main memory. So if it is a two-level paging, then two times you will access the main memory for get the page table, and then once you have to access the main memory to get the particular page. Is it clear? So what I want to say is that if the hit ratio is high, obviously the effective access time will be less. Let me discuss the formula for you. Okay, is it clear? So the effective access time is equal to hit ratio. Let's consider that P is the hit ratio, okay, of the TLB. Meaning is that, suppose if it says that 70% is the hit ratio, then meaning is that 100 times you are referring the TLB, then 70 times that information is available, TLB hit is happening. If 70 times hit is happening, 30 times miss is happening. So 70 by 100 is the hit. Okay, so P times the hit is happening. If hit is happening, we need to access the TLB once, and then we have to access the main memory once. Is it clear? Plus if it is a miss, okay, then you need to access the TLB once. If it is a single level paging, then main memory access to access the page table, then main memory access to access the particular information. Is it clear? I hope you are understanding. If it is a single level paging, if it is a multi-level paging, you can keep it here m into. Is it clear? Or you can write like this, small m into mm, where m is equal to number of page levels. If m is equal to 1, single level paging, m value will be 1. If it is a two-level paging, then m value will be 2. Is it clear? Are you able to understand? You can keep small m into main memory access, where m is the number of page levels, and then you have the main memory access. Is it clear? Now when this formula will work, whenever there is no page fault. What is meant by page fault? Whatever the page the CPU is accessing, that page is available in the main memory. If it is not available in the main memory, then we will say that it is a page fault. Then what will happen? There will be a trap, an interrupt will occur, then operating system will take control, and then it will get the particular page from the secondary memory and load it into the main memory. So the total time taken for servicing the page fault, we'll call it as page fault service time. Here I am assuming that there is no page fault. So whatever the CPU is searching for a particular page is available in the main memory. Is it clear? Are you able to understand? So if there is a page fault, then we have to add the page table page fault service time. Is it clear? So what is that one? It is nothing but bringing the particular page from the secondary memory and load it into the main memory. Is it clear? So with this information, I hope you have understood about the TLB. In the next video, I will discuss few numerical questions to understand the concept in a better way. Thank you for watching the complete video. Have a nice day.